Thank you, Lord, for your guidance and love. Thank you for this opportunity to present our thesis. Thank you for giving us these families who will help us improve the study. May this work be relevant and useful. We offer this work to you.
Ladies and gentlemen, we are the Tamadica Builders, and I am Noel Adam T. De Vera, presenting to you a research title entitled The Construction of Rectangular Covered Canal at Paraiso Street, Dumpay, Basista, Pangasinan. Water. Water is the most important substance on earth. All forms of life must have water to survive. There are many ways in which we can collect water, like surface water, excavated dams, rainwater tanks, bore, wells, and spring. Apart from drinking it to survive, it is also used for agricultural, industrial, and or recreational use. But even if water has a lot of advantages, it can also cause harm to all forms of life because of abundant water which causes natural disaster called flood.
Basista, Pangasinan consists of 13 barangays. The most often flooded areas are barangays of Dumpay, Cabaldatan, and Palma. But the most severely affected barangay is Barangay Dumpay. Out of all the barangays in Basista, Pangasinan, Dumpay is the most populated with a total of 5,586 people or 8.92% from the total population due to its area and location.
According to the Department of Environment and Natural Resources, Mine and Geosciences Bureau, Paraiso Street Barangay Dumpay, Basista, Pangasinan is categorized as a high flood susceptibility. In this area is experienced flood heights of 1 to 2 meter and or flood duration of more than 3 days. This area is immediately flooded during heavy rains of several hours. Include landforms of topographic lows such as an active river channel, abandoned river channel area along riverbank, also prone to flash flood. Paraiso Street, Dumpay, Basista, Pangasinan doesn't have canal. So we came up with an idea by construction of covered rectangular canal at Paraiso Street, Dumpay, Basista, Pangasinan to prevent flooding and to provide waterways from runoff water. The main objective of the study is to construct a covered rectangular canal at Paraiso Street, Basista, Pangasinan. Specifically, the study aimed to answer the following questions. The materials will be used to build this project, how much it will cost, and how long will it take the construction of the project. There are methods and procedures that we were used in order to collect data in conducting project studies are observation method, internet method, survey and interview method, group discussion method, library method, consultation method, and our perseverance.
Hello, my name is Lloyd Velasquez Caranco, a fifth-year civil engineering student, and I am here to present to you the interpretation and presentation of data. So the study focuses on the covered rectangular canal at Paraiso Street, Dumpay, Basista, Pangasinan. In analyzing the needed requirements for the study, we, as researchers, should have reliable data. The following information below was used as our basis for this project. The first one is the elevation leveling of the location. The second one is the rainfall intensity. The third one is the coefficient runoff and the rational method runoff coefficient. And the last is the area of the actual location of the project. So as you can see, this is the aerial shot of our project location. Here, the area is 61,985. So let's say this is 62,000 square meters. So we conducted profile leveling on Barangay Dumpay, Basista, Pangasinan. So here's the result. So here's the data coming from Dagupan, Pag-asa. And as you can see, from 2015, 2016, 2017, and 2018, and lastly, 2019, data that we collected as we can use in our computation. So first, these are monthly rainfall data from year 2005 to 2019. As shown in the tables, you can see the maximum total amount of rainfall in 1 month, RR, and the total number of rainy days in 1 month. This data will use to calculate the maximum discharge. So, to get the rainfall intensity, we have the rainfall in 1 month over rainy days in 1 month times hours. So is equal to 922.96 millimeter over 26 days times 1.5 hours is equal to 23.67. So let's say this is 30 millimeter per hour. So now we have a coefficient runoff and rational method runoff coefficient. So there's a data coming from Manning's coefficient, values of Manning's roughness coefficient n. So we use 0.018. And now let's go to the computation for the dimension of canal. So first we have the formula of Q equals to CIA. So what is it? First is Q is the discharge of the rain in cubic meter per second. C is 0.95, the runoff coefficient. This is based on the American Iron and Steel Institute. I is the rainfall intensity, which is 30 millimeter per hour, and A is the area, which is 62,000 square meter. So we will get Q equals to 0.95 times the quantity of 30 millimeter per hour times 1. This is the conversion of our solution. So times 62,000 square meter. So Q equals to 0.49 cubic meter per second. Next is the Q equals to AV. So first, what is Q? So Q equals to total discharge, A is the area of the canal, V is the mean velocity of the canal. And the last one is the Manning's formula, which is V equals to 1 over N times R raised to 2/3 times S raised to 1/2. So where N equals to 0.018, this is our roughness coefficient, S is 0.002, this is our slope, and R equals to A over P, or this is hydraulic radius. So A is the area and the P is the perimeter. Now, to find the V in terms of D, using the most efficient cross-section, where B equals to 2D. V equals to QA, where A equals to BD. V equals to Q over BD, where B equals to 2D. Therefore, we can get the first equation, V equals to Q over 2D squared. Next, using the Manning's formula, V equals to 1 over 0.018 times the quantity of 2D squared over 4D raised to 2/3 times 0.02 raised to 1/2. So we can get the D equals to 0.49, or let's say this is 0.5. So B equals to 2D, so our B equals to 1 meter. Now, for theoretical discharge, QT equals to AV. Assume that D equals to 1 meter and D is 0.50 meter for the most efficient section of rectangular canal. Area is equal to 0.50 meter squared and perimeter is 2 meter. So V equals to 1 over N times R raised to 2/3 times S raised to 1/2, where N equals to 0.018, S is 0.002, R equals to AP, and A equals to BD. Next, so V equals to 1 over 0.018 times the quantity of A over B times 0.02 raised to 1/2. So our Q is equal to 0.50 is greater than our Q actual of 0.49. So it is safe and it is good for our design. Next, the dimension of canal will be B equals to 2D, B equals to 2 times 0.5. So let's say B equals to 1 meter. So here, we have D equals to 0.50 plus 3 as allowance. So D equals to 0.80 meter. So let's say this is 1 meter. So the dimension of our canal will be 1 meter by 1 meter. Now we go to the computation of drainage canal in our slab, top slab. First, we have the FOC 21 MPa, Fy equals to 276 MPa. Our live load is equal to 38 kilonewton per meter squared. So here, the minimum thickness of slab is equal to H minimum equals to F over 20 times the quantity of 0.40 plus F of Y over 700. So H min is equal to 39.71 times 2, say 80 millimeter thickness of slab is our H minimum. Next is H equals to clear cover plus main bar diameter plus temperature bar diameter plus height of concrete. So H will be 25 millimeter plus 12 millimeter plus 12 millimeter plus 76 millimeter. Adding 76 millimeter for concrete compression to make it at least 125. So our H equals to 125 millimeter. So D is equal to 125 millimeter minus 25 millimeter, which is our clear cover, minus the 1/2 diameter of 12 millimeter. So our D is 94 millimeter. So now, consider 1 millimeter or 1 meter strip of our slab. So weight of slab is equal to WS, or equal to gamma concrete times base times height. So our weight of slab is equal to 23.54 kilonewton per cubic meter times 1 meter times 0.125 meter. So our W, or our weight for the slab, is 2.94 kilonewton per meter. Next is consider again the 1 meter strip of our slab. So live load is equal to 30 kilonewton over meter squared times 1 meter. Therefore, our live load is equal to 38 kilonewton per meter. Now we proceed to get the ultimate load. So ultimate load is equal to 1.2 dead load plus 1.6 live load. So W is equal to 1.2 times 2.94 kilonewton per meter plus 1.638 kilonewton per meter. So our W is equal to 64.328 kilonewton per meter. Next is the moment ultimate is equal to 1 over 8 WL squared. So mu is equal to 1 over 8 times 64.328 times 1.250 squared. So therefore, our mu is equal to 12.56 kilonewton meter. Next, Rn is equal to mu over 0.90 times B times D squared. So our Rn is equal to 1.579397,415. Next, P is equal to 0.85 f of c over f of y times the quantity of 1 times minus the square root of 1 minus 2 Ru over 0.85 f of c. So we get P equals to 0.006. Now to get the P minimum is equal to 1.4 over f of y. So P minimum is equal to 0.005. And lastly, the P max is equal to 0.75 times 0.85 times B or beta times 600 over 0.85 times f of c. So our P max is 0.028. Therefore, use P 0.006. So area of our steel is equal to P times B times D. So AS is equal to 0.006 times 1000 times 94. Therefore, our area is 564 millimeters squared. Using 12 millimeter bar for our main bar, N equals to 564 over pi over 4 times 12 squared is equal to 4.98, or let's say 5 bars. For our spacing, S is equal to pi over 4 times the quantity of 12 squared over 564. So our spacing is 200 millimeter on center. Now, we go to the design of the image cover. First is we have the F of C is equal to 21 MPa, F of Y equals to 276 MPa. Our dead load is 24 kilonewton per meter squared, and our live load is equal to 35 kilonewton per meter. Now, consider the 0.5 meter strip of our cover. So our dead load is equal to 12 kilonewton per meter. The next one is our live load. Live load is equal to 35 kilonewton per meter, and our ultimate weight is equal to 1.2 TL plus 1.6 LL, or our live load. Therefore, our WU is equal to 70.40 kilonewton per meter. Now we go to the MU, or we call it maximum or ultimate moment. So MU equals to 1 over 8 WL squared. So MU is equal to 1 over 8 times 70.40 times the quantity of 1.15 squared. Therefore, our MU is equal to 11.638 kilonewton meter. Now, we go to the Rn. To solve the Rn, the formula is mu over 0.90 b times d squared. Therefore, we will get Rn is equal to 2.92691545. So, to get the P is equal to 0.85 f of c over f of y times the quantity of 1 minus the square root of 1 minus 2 Rn over 0.85 f of c. Therefore, we will get P is equal to 0.0116. And our P minimum, P equals to 0.005, and our P max is 0.028. Therefore, we will use the P is equal to 0.0116. Next, for our area, A equals to PBD. A equals to 0.0116 times 500 times 94. Our area is 545.2 millimeters squared. Using 12 millimeter bar for our main bar, N is equal to 545 over pi over 4 times the quantity of 12 squared is equal to 4.82. Let's say this is 5 bars. Next, we will go to the spacing. So S is equal to 500 minus 2 times 25 minus 2 times raise times the quantity of 12 over 2 over 5 minus 1. So S is 200 millimeter on center. So this is the actual design of our drainage cover or for the manhole. Next, we proceed to the design for the side walls or the drain wall. So use F of Y equals to 276 MPa. Our F of C is equal to 21 MPa. So this is the diagram for the clear explanation of our design. So we have the surcharge load. The unit weight of concrete is 23.54 kilonewton per cubic meter, and our unit weight of soil is equal to 18 kilonewton per cubic meter. So our W1 here is 23.54 times 0.30. So our W1 is 7.10 kPa. The next one is W2. W2 is the 18, or the W2 is the 18 kilonewton per meter square times 1. So our W2 is 18 kPa. Next one, to get the P1, P1 is 7.10 times 1. Therefore, P1 is 7.10 kilonewton per meter. The next one is to get the P2. P2 is 18 times 1 over 2. Therefore, our P2 is 9 kilonewton per meter. Now, to get the R is equal to 7.10 plus 9.00. R equals to 16.10 kilonewton per meter. So, 16.10 times Y is equal to 7.10 times 0.05 plus 9 times the quantity of 1.1 over 3. So, our Y is equal to 0.41 meter. So, next is consider the cantilever slab, take 1 meter straight. So our Y given, Y equals to 0.41, R is 16.10 kilonewton. So our M is equal to 16.10 times 0.41. Therefore our M is equal to 6.60 kilonewton meter. So go back to our formula, M equals to Rn B times D squared. So our Rn is equal to Mu over 0.90 times BD squared. So Rn equals to 0.000000829. The next one is to get the P. P is equal to 0.85 f of c over f of y times the quantity of 1 minus the square root of 1 minus 2RU over 0.85 f of c. Therefore, we get the P is equal to 0.000000003. Next, our P minimum is equal to 0.005 and our P max is 0.028. Therefore, we will use the P 0.005. So for the area, AS is equal to PBT. AS is equal to 0.005 times 1000 times 94. So our AS is equal to 470 millimeter squared. Using 12 millimeter bar or our main bars, N is equal to 470 over pi over 4 times the quantity of globe squared is equal to 4.15 or let's say 5 bars. For spacing, S equals to pi over 4 times 12 squared over 470 is equal to 240 millimeter on center. For checking for our D, MU is equal to 0.90 area or AS times f of y times d times the quantity of 1 minus 0.59 f of y over f of c. So we get the d is equal to 58.81 millimeter greater than 94 millimeter. It is safe and okay. Next, we will go to the design of bottom slab. First, we will use again the f of y is equal to 276 MPa, f of c is equal to 21 MPa, and the span of slab is equal to 1250 millimeter, and consider the 1000 millimeter. So again, the minimum thickness of slab is equal to H minimum is equal to 39.71 millimeter. So our H is equal to clear cover plus main bar diameter plus temperature bars diameter plus height of the clear is equal to H equals to 25 millimeter plus 12 millimeter plus 12 millimeter plus 76, adding 76 millimeter for concrete compression to make it at least 125 millimeter. So our H is equal to 125 millimeter. Therefore, our D is equal to 125 minus 25 millimeter for our clear cover minus 1/2 bar diameter of 12 millimeter. Therefore, our D is equal to 94 millimeter. So next, weight of slab. WS is equal to Y concrete times base times height. So WS is equal to 23.54 times kilonewton per WS is equal to 23.54 kilonewton per cubic meter times 1 meter times 0.125 meter. Therefore, our WS is equal to 2.94 kilonewton per meter. Next, consider again the 1 meter strip. The live load will be 9.81 kilonewton per meter squared times 1 meter is equal to 9.81 kilonewton per meter. Next is the WU, or the ultimate weight, is equal to 1.2 dead load plus 1.6 live load. So our WU is equal to 1.2 times 2.94 kilonewton per meter plus 1.6 times 9.81 kilonewton per meter. So our W is equal to 19.244 kilonewton per meter. Next, our MU is equal to 1 over 8 WL squared. MU is equal to 1/8 of times 19.244 times the quantity of 1.250 squared. So our MU is equal to 3.75 kilonewton per meter. Next is to get the RN value. RN is equal to MU over 0.90 BD squared. So our RN is equal to 3.75 times 10 raised to 6 over 0.90 times 1000 times 94 squared. So our RN is equal to 0.471558. So our P is equal to 0.85 f of c over f of y times the quantity of 1 minus the square of 1 minus 2RU over 0.85 f of c. Therefore, our P is equal to 0.00173. Next, to get the P-min, our P-min is equal to 1.4 over f of y. Our P-min is 1.4 over 276, so we will get 0.005. And our P-max is equal to 0.75 times 0.85 times beta times 600 over 0.85 f of c. So our P-max is equal to 0.028. Therefore, we will use the P is equal to 0.05 or 0.005. Next, for the area, AS equals to PBT. AS is equal to 0.005 times 1000 times the 94. So our AS is equal to 470 millimeter squared. Using 12 millimeter bar for our main bars, N is equal to 470 over pi over 4 times 12 squared is equal to 400 or is equal to 4.15. So let's say 5 bars. For spacing, S is equal to pi over 4 times 12 squared over 470. So the spacing is 240 millimeter on center. Checking for the D is MU is equal to 0.90 times AS f of y times D times the quantity of 1 minus 0.59 f of y over f of c. So 3.75 times 10 raised to 6 is equal to 0.90 times 470 times 276 times D times the quantity of 1 minus 0.59 times the quantity of 0.005 times 276 over 21. So our D is equal to 28.97 is greater than 94 millimeter. So our D is safe. Thank you.
Hi, I'm Benedictino Maraldo, your next supporter. So for our next topic is the material estimate. For the reinforcing steel, bar type 1 using 12mm bar, unit weight 0.88 kg per meter. The total weight of bar type 1 is equal to 6.21 kg. For the bar type 2 using 12mm bar, unit weight 0.888 kg per meter. The total weight of bar type 2 is equal to 4.440 kg. For the bar type 4, using 10mm bar, unit weight 0.617 kg per meter. The total weight of bar type 4 is equal to 9.872 kg. For the bar type 5, using 12 mm bar, unit weight 0.888 kg per meter, the total weight of bar type 5 is equal to 16.872 kg. So for the total weight of reinforcing steel, we have 37.4 kg per linear meter of concrete covered canal. So these are the schedule of reinforcement per 1 meter street. H is equal to 1,000 meter concrete covered canal. For the total weight of bar for 368 meter is equal to 13,763.20 kg. Reinforcing steel for bar type 1 using 12 mm bar, unit weight 0.888 kg per meter. The total weight of bar type 1 is equal to 11.3664 kg. For the bar type 2, using 12 mm bar, unit weight 0.888 kg per meter, the total weight of bar type 2 is equal to 2.3088 kg. For the bar type 3, using 12 mm bar, unit weight 0.888 kg per meter, the total weight of bar type 2 is equal to 3.1968 kg. For the bar type 4, using 10 mm bar, unit weight 0.617 kg per meter, the total weight of bar type 4 is equal to 9.872 kg. For the bar type 5, using 12 mm bar, unit weight 0.888 kg per meter, the total weight of bar type 5 is equal to 16.872 kg. So for the total weight of reinforcing steel, we have 43.616 kg per linear meter of concrete covered canal. So these are the schedule of reinforcement per 1 meter street. H is equal to 1,000 meter with removable cover. So for the total weight of bar for 72 meter is equal to 3,140.352 kg. So for the summary for reinforced steel bar, for the 10 mm bar, RSB is equal to 4,343.68 kg. Say we have 4,344 kg. For the 12 mm bar, RSB, we have 12,558.872 kg. Say we have 12,599 kg. Next is the concrete works. So for the volume of the top slab, we have 0.15625 cubic meter. And for the volume of the bottom slab, we have 0.15625 cubic meters. So next is the two drainage walls. The total volume will be 0.25 cubic meter. So for the total volume of concrete covered canal per linear meter, we have 0.5625 cubic meter per linear meter of concrete covered canal. So these are the estimate of quantities per linear meter. For class A, we have, for the quantity, we have 0.56. Total volume for 368 meters, we have 207 cubic meters. These are the complete portion coming from Max B. Fajardo. Use class A, concrete covered canal. Total volume will be 207 cubic meter. For the cement, 1,863 bags. For the sand, we have 103.5 cubic meter. For the gravel, we have 207.0 cubic meter. Concrete works. For the top slab, we have 0.10 cubic meter. For the bottom slab, we have 0.15625 cubic meter. For the two drainage walls, we have 0.25 cubic meter. And for the total volume of concrete covered canal per linear meter, we have 0.50625 cubic meter per linear meter of concrete covered canal with removable cover. So these are the estimate of quantities per linear meter. For the total volume for 72 meter, we have 40.50 cubic meter. Concrete proportion refer from Max B. Fajardo estimate. Use class A, concrete covered canal. Total volume 40 cubic meter. For the cement, 364.5, say 365 bags. Sand, 40.5 cubic meter times 0.50 is equal to 20.15 cubic meter. For the gravel, we have 40.50 cubic meter. Concrete works, manhole and or removable cover. For the volume, we have 0.14375 cubic meter per linear meter. For using class A, we have total volume equals to 10.35 cubic meter. For the cement, we have 93.15 bags, say 94 bags. Sand, we have 5.175 cubic meter. Gravel, we have 10.35 cubic meter, is equals to 10.35 cubic meter. So for the summary, for the cement, we have 2,322 bags. For the sand, we have 128.925 cubic meter, say we have 129 cubic meter. For the gravel, we have 257.85 cubic meter, say we have 258 cubic meter. For granular bedding per linear meter, using 3/8 drainage aggregates, the total volume will be 59.40 cubic meter. For the formworks, using 1/2 by 4 by 8 marine plywood. For the top slab, the total area will be 550 square meter. For the 2 drainage walls, total area will be 1,760 square meters. Next, the manhole or removable cover. Total area will be 29.7 square meter. So for the summary, using 1/2 by 4 by 8 marine plywood, the total area will be 2,341.7 square meters. For the number of pieces, we have 240.013, say 241 pieces. For binding wires, next is the concrete cover canal. 37.5 kg per linear meter of concrete cover canal. We have 165.1584 kg. For the concrete cover canal with movable cover, we have 37.6842 kg. For the summary for number 16 tie wire, total requirement of binding wires is equal to 202.843 kg, say 203 kg. Number 2 by 2 by 12. Nails required. We have approximately kilogram of nails required is 77.2761, say 78 kilogram. Bill of materials and cost estimates. For earthworks and machinery, we have a total cost of 108,532 pesos. For the concrete and masonry works, we have a total of 1,606,032 pesos. For the carpentry works, we have a total cost of 226,755 pesos. Overall, the total will be 1,951,319 pesos. For the labor cost, we have a total of 971,200 pesos. So for the total project cost, we have 1,951,319 pesos. For the labor cost, we have 971,200 pesos. For on-cost materials, 12%, we have 234,158.28 pesos. For the cost profit, 10%, we have 97,120 pesos. For the VAT, 5%, 16,563.91 pesos. For the total project cost, we have 3,270,363.19 pesos.
My name is Michael Dumpay, and my parts to report is construction flow of works with manpower computation. First is preparation of the location project. A1, clearing and grounding. This to complete is 1 day. A2, disposal of stripe, considering all materials to be disposed. D2, dispose is 1 day. A3, hauling. This to complete haul is 1 day. Delivery of materials, days to complete is 4 days. A5, canal excavation. Days to complete excavation is 2 days, save 4 days in case of inable scenarios. A6, clearing of usage materials and clearing. Days to complete is 1 day. Second is building construction. B1, screening and granular base. Days to be complete is 2 days. B2, delivery of the materials. Days to complete is 4 days. B4, bottom slab, concrete and flooring. Days to complete mix is 2 days. B4, fabrication and installation of reamers. Days to complete is 30 days. B5, form of works for the sidewalks. Number of days to complete is 4 days. B6, flooring and concrete for drainage walls. Days to complete mix is 2 days. B7, concrete vibrator. Days to complete vibrator, 2 days. B8, dismantling of the formworks. 2 days to complete, 2 days. Third is construction of top slab. C1, formworks of the top slab. Days to complete is 2 days. C2, fabrication and installation of rebars. Number of days to complete is 10 days. C3, flooring and concrete on top slab. Days to complete mix is 1 day. C4, dismantling of the formworks. Days to complete is 2 days. Fourth is construction of removal cover and manhole. D1, fabrication and placing of board. Number of days to complete is 1 day. D2, fabrication and installation of rebars. Number of days to complete is 4 days. D3, delivery of materials. Days to complete is 2 days. D4, flooring and concrete on manhole and removal cover. Days to complete mix is 1 day. D5, dismantling of the formworks. Days to be complete is 1 day. D6,
Hello, I'm back.
placing and removal cover to the manhole. Day to be complete is 1 day. Materials and cleaning. Days to be complete is 1 day.
For the summary of our project study, the project title is Construction of Rectangular Canal at Paraiso Street, Dumpay, Basista, Pangasinan. The location is at Paraiso Street, Dumpay, Basista, Pangasinan. The construction of covered rectangular canal at Paraiso Street, Dumpay, Basista, Pangasinan has a length of 440 meters. The canal is a rectangular with a side equal to 1.250 meter by 1.250 meter. And the total project cost
is 3,270,363.19 pesos. This project is greatly help to the people living at Praisi Street, Dumpay, Basista, Pangasinan, especially to the people who are working every day and to the student of Dumpay National High School because it will prevent flooding in their barangay that causes a lot of inconvenience and loss. This project will also assure the safety of the residents and to avoid getting different diseases from the flood. The development plan of the area could lessen the problems of the people living there. This would be very helpful because it could give assurance and safety not only for the residents of this barangay, but also for the instructor and students of Dumpay National High School by minimizing the occurrence and the severity of the flood. In order to accomplish the main goal of this research, that is to provide residents of Paraisi Street, Barangay Dumpay, a convenient canal or drainage system, the construction of covered rectangular canal must be taken into action. Cut mo to. Since canals are the only type of outlet that we can utilize as a part of our drainage system, we as the researchers, we recommend to seek for another drainage system to be used in the future studies. The proper execution of geotechnical engineering is highly needed in order to know the type of soil to be drilled of the best one that is suited for the construction.